So, to see ARP in action, what I'm going to first do is talk a little bit about the Internet Protocol suite and the layers that we're talking about. So, what the IP suite does is it breaks the packets that we talk on about into four different layers. So we have at the bottom this link layer. So link layer is the link that you're on, and the IP suite specifically does not actually say what that link is. And this is because when you're on the backbone on the internet, a lot of the time you're not going to be talking Ethernet, you're going to be talking various fiber protocols. But then when you're in like a LAN environment, in a house, you will be talking Ethernet. So they want the same stack to apply to every different physical link layer. So what they say is there is a link and it's up to the link layer how it handles it. Then we go up the stack one and we've got this internet layer, or the IP as in Internet Protocol layer. And so we have in the Internet Protocol layer our IP header and then our IP data. Now within the IP data, this is where the actual transport layer is stored. In this case, it's showing UDP. However, for our example that we've been looking at, we will be talking TCP, Transmission Control Protocol. And then at the top, we have the application layer. So this is just data. Once it reaches the endpoints, these are applications talking. And from that point on, the Internet Protocol suite doesn't actually care what is inside that data. It's up to the applications to handle it. Now, the application may do more on top of that data layer. They may implement their own extra layers. And in the case of what we're seeing, we actually will see that. We'll see two protocols, TLS, the Transport Layer Security, and HTTP, the Hypertext Transport Protocol, I believe it is, HTTP. So there's actually two layers that are going to be encapsulated in this data, but to the IP suite, it doesn't matter. It's just data that is transferring back and forth. So to actually see the data packets in action, I have here a tool called Wireshark, and Wireshark is capturing from ENP39S0. And as you recall, we have ENP39S0. This is the device or the Ethernet interface that we are talking on. This is the interface that we're going to be performing ARP on to actually find the Ethernet address of 10111, the router that we want to send our packets via. Now, you can see that my computer is very busy. There's a lot going on here. So what we're going to do in Wireshark is we're going to use this filter at the top to actually start cutting down the packets we see. We don't want to see everything. We just want to see the specific ARP packets that I'm showing today. So we can actually use some search filters here, and Wireshark is very smart. It knows a lot about what the packets that are on the link are. So I can actually just type ARP and it will now show me only ARP messages. What we can actually see here is a lot of ARP messages going on. And this is where I was saying earlier, you can see all these source addresses. So all these source addresses, these are the Ethernet MAC addresses. So we see these MAC addresses and then the destination is broadcast for a lot of these ARP messages. And if we have a look in this pane here, we can see a bit of information about the Ethernet frame. So we have here our source is this MAC address and our destination is broadcast. So FF. Basically all ones. That is the Ethernet syntax. If you set every hardware address bit to 1, what that is it is a broadcast. So send it to every device on the link. Okay, so this, however, is actually too noisy for me to demonstrate the ARP request that we care about. So what I've actually saved here is the specific ARP search that I can use to show just the ARP request that we care about, okay? So I'll actually go through it. What we have is ARP, so we only care about ARP packets, and we're using the double and ampersand symbol here. That's like the and. We can also literally just type and Wireshark understands that. And then we're saying we care about these two other things. So the ARP source hardware MAC address is equal to 00D8 blah 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 blah, a MAC address. So what is that MAC address? Well, let me type IP link, and this will show me information about the links on my own computer. And you can see here's our link interface that we care about. And you can see there is the Ethernet MAC address. So what I've done is I've put in the MAC address of my link. So I want to see only ARP addresses where the source is my MAC address, or ARP messages where the destination is my MAC address. So because all these broadcast links arrive at every device on the network, we don't want everyone's ARP messages showing up in Wireshark. We only want the ones to me or from me. And now I can hit enter on that search, and you can see it's filtered down the messages a lot. Now what I'm going to do is I'm going to restart this current capture. So I'll just do that, and now we can see we have an empty capture. And I've saved this command here. Now, when you do an ARP request, your computer will remember the ARP result for a while. So what I'm going to do here is do two commands. So I'm going to sudo ARP delete the ARP entry for that IP address, and then I'm going to rerun the ARP for that IP address. So this is just to delete it from the memory of the computer so that we can see the packet again on our Wireshark capture here. So let me restart this again, hit enter on that command, and then we can stop this capture, and we have here some packets. So now if I do sudo ARP for that, we should have an entry in the ARP entry, and we can see that the address is _gateway. So this is the resolved name and the hardware address here, and also the interface that address is on. Okay, so let's dig a little into the packet capture. Now, these two packets at the top, these are the packets that I care about. So what we have is the first packet. So this is when I ran this ARP delete, and then I did an ARP request for that IP address. So what we can see is that we sent out these Ethernet packets. So they're both Ethernet, and they both contain address resolution protocols. So the first one, we can see that the source MAC address, now that is the MAC address of my computer, as we expected. The destination MAC address is the broadcast address. And what we put in the Ethernet packet is ARP, the address resolution protocol. And this is the first request where we are broadcasting to the network. This MAC address, am looking for a target MAC address, IP address. So we send it out to everyone. We say we don't know yet what the target MAC address is, and so we set all of our MAC address of the targeted MAC address to zeros. We set this is my IP address, my MAC address, and I'm looking for this IP address. And the important thing here also is the opcode. So this is an ARP of type request. Next, we get back a second Ethernet packet. Now here we actually have a source MAC address. So the destination MAC address, so the packet was sent from this source MAC address to this destination MAC address, and that is my MAC address. So we've received a packet back, and it's from this source MAC address, and it contains ARP. Now, this time we have the opcode being reply. So this is what we want. We want the gateway to respond to us and say, oh, you're looking for my MAC address. I have that IP address. So the sender's MAC address is this. The sender's IP address is 111, which is what we want. And then it's sent it to the target MAC address, so to our MAC address and the target IP address. So this packets come back to us. We can now store in our memory the hardware address of this IP address 10.1.1.1. So we've actually resolved now that link layer. We need to send packets to 103. We need to send them via 10.1.1.1, and we need to know the Ethernet address of that IP address. And we now have it here. It's this CE, CC, etc. So I will now make a copy of that so we can add that to the information we've collected.